this is all about trigonometric substitution. Okay, so there are three different cases for this. So we're going to have one where we have an a squared minus x squared. Number two is the case where we have other way, x squared minus a squared. And then we have the third case, which is totally different, x squared plus a squared. And as we all know, these two can be switched because addition, it doesn't matter the order. Okay, and then for all three of these, x is just x, so its own independent variable, and a is a constant. Okay, so a is just some number that we know. Okay? All right, so let's get started with the first version. So number one, this is when a squared minus x squared. Okay, so in this case, what we're going to be doing is actually kind of switching over to, it's sort of like a type of u substitution, except for now we're going to be using theta, the Greek letter theta. So I'll show you it's kind of like a transformation in a way. So our x is actually going to equal a sine theta. Our dx is just the first derivative of this, so it's a cosine theta d theta. And our a squared minus x squared is going to equal a cosine theta. So right now it looks kind of confusing. It's like, what are these? I don't even know why are we switching over into Greek letters and all of this, but it'll make sense once we apply it to a problem. So let's do a problem. We have, let's say we're given x over square root of 9 minus x squared. Okay, and then dx, of course. So as you can see on the bottom, this is in the format of a squared minus x squared, right? Where our a equals 3. Okay, so what we can do here, right now, well, technically this problem can be solved just by using u substitution, but we're going to do it in this other trigonometric substitution way, just for demonstrative purposes. Demonstrative? I don't know. Anyways, so we're actually going to have, we're going to plug in our a and theta into these formulas. So x is going to equal a, which is 3 sine theta. Okay, I'm going to draw a line here so you don't get confused. So the top is like our guidelines, and then this is our actual problem. Our dx is going to be 3 cosine theta d theta, and our whole thing on the bottom, 9 minus x squared, is going to equal 3 cosine theta. Okay? So what we do now, once we have these three values, is just plug them in for the spots. So for x, we're going to plug in 3 sine theta. So this thing is going to equal 3 sine theta, right, in the x spot, over, and for the square root spot, we're going to have a 3 cosine theta, right, because that's what we found. And for dx, we're going to have times a 3 cosine theta d theta. And in this case, it cancels quite conveniently, so that both the 3 cosine theta and on the top and the bottom cancel. So we're left with this. And yeah, if you have good hearing, then you'll probably hear the dogs in the background. I'm sorry. We have dogs. Okay, so moving on, we're actually going to simplify. So 3 sine theta d theta. Okay, and then I'll move on to the next slide. Here we go. So this turns into a negative 3 cosine theta plus c. Okay, and then as for a final step, though, we can't leave it in terms of theta. We have to replace with x. So replace with something that involves x. Replace with x. Okay, so what we had before is we knew that 3 cosine theta, this is one of our equations, was 9 minus x squared. Okay, so to get cosine by itself, so we can plug it in, that's the same thing as 1 over 3 times the square root, right? Okay, so we're just going to plug this back into the cosine theta spot, and then we'll have our final answer. So negative 3 times 1 over 3 square root thingy, and then that's that, plus c. So the 3's here cancel, and our final answer is going to be a negative square root 9 minus x squared plus c. Okay? So that does it for case number 1. Now let's move on to number 2. So case number 2 is when we have it, the x spot and the a's are, the x's and the a's are switched. So then we'll have x squared minus a squared. Okay? So the 3, I guess, like mini formulas here are x equals a secant theta, dx consequently equals a secant theta tangent theta, d theta. Okay? And then our square root part, this whole thing equals a tangent theta. Okay, so let's do a quick problem for this one, just to show you again. So let's say we have x over x squared minus 4. So as you can see, the x comes first and the a comes last. So our a in this case, what squared equals 4? That would be 2. Okay, so our mini formulas here would be plugging in the 2, so we get 2 secant theta. Our dx is now 2 secant theta tangent theta d theta. And our square root, x squared minus a squared, is equal to 2 tangent theta. Okay? Alright, so now we're going to plug these in. Oh, I'm sorry, there's a dx here. That would have been mathematically wrong. Okay, so if we plug them in, then we're going to get integral 2 secant theta on top, right, in place of the x. And on the bottom, we're going to have 2 tangent theta. Okay, and then times the dx, which is the long thing. So 2 secant theta, tangent theta, and a d theta. And then this is my favorite part, the whole canceling out of things, because that means everything's getting simpler. So we can cancel out the 2's here, and the tangent on the bottom, tangent on the top. Okay, so we're left with, let's see, we have 1, 2 left over, so we have a 2, and then integral of secant squared theta d theta. Okay, and then I'll just move on to the next slide. So as we all know, the integral of secant squared theta is going to be a, so we have the 2 in front, tangent theta, right? And then plus c, okay, because it was an indefinite integral. And then our last step is replace with x, so we need something in terms of x here. So as we knew from the beginning, when we made our mini formulas, x squared minus 4 equals 2 tangent theta. So then to get tangent by itself, that's just going to be half of the square root. Okay, so x squared minus 4. Alright, so we're going to plug this in for the tangent spot, and then we will be done. Okay, so 1/2 x squared minus 4 for that spot, and then we have our plus c. So the 2's cancel, and our final answer is just x squared minus 4 plus c. Okay? Alrighty then. And then I'm just going to go over the mini guideline formulas for case number 3, but we're not going to do an example for this because it works basically the same way as the other 2 did. We'll see problems like this on homework too. So here's the third case, a squared. And then so our other formulas will be a tangent theta. Our dx will be a secant squared theta d theta, right? And then our square root part will be, so x squared plus a squared equals a secant theta. Okay? So this will work the same way as the previous 2. So we don't need to worry about that too much.